Welcome to the General Chemistry High Impact module on the mole concept, part one, where we'll take the mole concept and introduce it, apply it to Avogadro's number and molar mass. So most of us are familiar with the concept of a dozen, where a dozen means 12 things, like these 12 tasty donuts in an order of 1 dozen donuts. And the equivalency is that a dozen is equal to 12 things, or we can think about it as 12 things per dozen, or 1 dozen per 12 things. While a baker might use a unit of a dozen to describe an order of 12 things, the chemists use a unit called a mole, and a mole numerically is equal to 6.022 times 10 to the 23rd, also known as Avogadro's number. So if we have a mole of things, we have 6.022 times 10 to the 23rd of those things. And the equivalency is 6.022 times 10 to the 23rd things per mole of things, or 1 mole of things per 6.022 times 10 to the 23rd of those things. So let's apply our dimensional analysis skills and convert things to number of things. So if we have 3.5 dozen things, we know the unit conversion for that is 12 things per dozen. Multiply that out and we get 42 things in 3.50 dozen. Now, to be fair, Avogadro's number, or 6.022 times 10 to the 23rd things in a mole, is a really intimidating number because it's so huge, we can't even comprehend it. But just think of it as a number and use it as a unit conversion factor. So there are Avogadro's number, or 6.022 times 10 to the 23rd atoms of gold per mole of gold. Run that calculation, account for significant figures, and you get 1.89 times 10 to the 24th gold atoms. The mole concept and Avogadro's number of 6.022 times 10 to the 23rd also applies to molecules like carbon dioxide. 1 mole of carbon dioxide is equal to 6.022 times 10 to the 23rd carbon dioxide molecules. And when we cancel out the units of moles over units of moles, we're left with carbon dioxide molecules. Run that calculation, and again, we get 1.89 times 10 to the 24th carbon dioxide molecules. Now, look at the formula for carbon dioxide, CO2. 1 molecule of carbon dioxide has 1 carbon atom and 2 oxygen atoms. So in this question about 3.14 moles of carbon dioxide, what if we asked for the total number of oxygen atoms? So again, we would keep this conversion going the way it was originally set up, only we would add one more caveat. For every 1 carbon dioxide molecule, there are 2 oxygen atoms, giving us the total number of oxygen atoms in 3.14 moles of carbon dioxide. We can use the relationship of Avogadro's number, 6.022 times 10 to the 23rd, and 1 mole to convert number of things to moles of things. So if we start off with 9.0 times 10 to the 22 things, and we use the conversion factor, 1 mole per 6.022 times 10 to the 23rd things, we get our final answer of 0.15 moles of things. An important question to ask is, what is the mass of a mole of things? Well, a mole of different elements doesn't necessarily have the same mass. If we take a look at gold on the periodic table, we're going to find it under elemental symbol Au. We're going to see that it has 79 protons in its nucleus, and we see its average mass here, 196.967. And again, what does this number actually mean? One atom of gold has 196.967 atomic mass units, but we don't deal on the individual atom scale. The other way to treat this number is that 1 mole of gold atoms has a mass of 196.967 grams, a gram unit and a mole unit. And this gives us the new unit equivalency called molar mass, or grams of a substance per 1 mole of that substance. So let's go ahead and use that in a unit conversion scenario. If we start with 3.14 moles of gold, use the molar mass to convert to grams of gold. Grams over mole cancels out moles, gives us our answer in grams. And we can use that same molar mass for gold if we convert 5.0 grams of gold to moles of gold.